Hello, Math 1050. This is Mrs. Bricky, and this lesson is 7.1. We're going to be talking about ellipse today. In Alex, you'll have 3 topics. So an ellipse is one of the 4 conic sections. A circle is also a conic section. So right now I have a circle on the screen. A circle by definition is all of the points that are equidistant from a fixed point that is called the center. So an ellipse is like a circle that gets elongated. It still has a center, but it also has 2 foci, and these are 2 points that sort of determine the size of the ellipse. And so the definition of an ellipse, one of the definitions of an ellipse is that it is all of the points that are a fixed distance away from 2 foci. So point A right over here and point B over here are the foci of this ellipse, and the distance, the pink distance A from point A and the green distance B from point B, the sum of those 2 distances is always 16. So like I can move, I can move point D around, and as the green one gets shorter, the pink one gets longer, but the sum of those 2 distances is always 16. So that's what an ellipse is, and that's what this lesson is about. Our first topic is that we're going to be graphing an ellipse. So the form of an ellipse equation is like this one on the screen. It kind of maybe reminds you a little bit of a circle equation. A circle equation looks like this. If we wanted to make this look more like an ellipse equation, we would divide by the r squared so that we would have a 1 on the right side of the equation. And if we divide everything by r squared, it looks a lot like an ellipse equation. In fact, it is an ellipse. A circle is a type of ellipse, sort of like a square is a type of rectangle. And so a circle is an ellipse that has the same 2 numbers in the denominator. An ellipse doesn't have to, like the one we're going to graph, has a denominator of 16 and a denominator of 25. Okay, so really kind of similar to graphing a circle. So when you're graphing an ellipse, you want to start with the center point, and the center point comes from these 2. So our center point is going to be at -2, -3. And then, if we were graphing a circle, which we've done earlier this semester, you would maybe count out by that radius amount in 4 directions. So like 3 and 3 and 3 and 3, for example, would make a nice little circle. An ellipse is a lot like that, but the distance to the left and the right of the center and the distance between the point above the center and the point below the center, it doesn't have to be the same. So if you look right here, below the x squared, we have 25. Well, 25 is the same as 5 squared. And so in the x direction, I'm going to count out 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then in the y direction, you see a 16 underneath the y to the third, the y plus 3 squared. So that would be a 4 squared. And so in the y direction, I'm going to count out 4. So the amount we count out is just different in the x and the y direction. And that gives you sort of that, is a really bad ellipse, sort of a circle that maybe got squished a little bit in one direction. So whichever one is longer is called the major axis. So this ellipse has a major axis of 5, and the minor axis is the one that is shorter. So this one is a minor axis of 4. And a circle is an ellipse where the major and the minor axis are just the same length. So this one is not very elongated. It almost is a circle. Let's look at one that's a little more elongated. We have the ellipse x minus 2 squared plus y plus 3 squared divided by 16 is equal to 1. You'll notice that first term, x minus 2 squared, does not have a denominator. We need to think of that as a denominator of 1. So the center of this ellipse is going to be at the point 2, -3. In the x direction, we have a 1. That's the same as 1 squared. So we're going to just count out 1 in the x direction. So it's very narrow. In the y part of the equation, we have a 16. That's a 4 squared. So we're going to count from the center up 4 and from the center down 4. And that will determine our little ellipse. So this one's a lot more elongated than the last one we graphed. So the minor axis is 1 and the major axis is 4. Okay, when you do graph those in Alex, it's very easy. You'll mark the center, you'll mark the x or y direction axis, and then you'll mark the other one, and then it will draw the ellipse. So very easy to graph in Alex. Okay, we've already talked about a couple of these things, but we'll talk about a couple more leading up to our next topic. So your ellipse can have a horizontal major axis or a vertical major axis. It can be a wide ellipse or a tall ellipse, maybe is an easy way to think about it. And it really just depends on whether the number under the x squared is larger or whether the number under the y squared is larger. Whichever one is larger is going to be the major axis direction. So the next topic is going to have you find 5 points that are five characteristic points of an ellipse. So the first point it is going to have you find is the center, and we already practiced finding the center using when we were graphing just barely. And then it's also going to ask you to find 4 additional points. 2 of the points that you need to find are the vertices. So just always along the major axis, the farthest points are called the vertex. Each of them are called a vertex, so there's 2 vertices. So you'll find those 2 points, and then also it wants you to find the 2 foci. Now those are the 2 points where the distance, the sum of the distance between those 2 points and the edge is always the same. So like this segment plus this segment is going to always be a constant fixed amount. So we're going to find those 5 points for each of our ellipses. They are always, always, always going to fall along the major axis, either a horizontal major axis or a vertical major axis. You can probably see from graphing how to find the center and the 2 vertices, but the foci are a little bit different to find. So on your Utah Tech formula sheet, it has this standard form of an ellipse equation centered at HK, and it has at the end of that paragraph, the foci are C units from the center along the major axis, where C is equal to a squared minus b squared. They have absolute values around here. That's just because we definitely want this to be a positive number. If a is the major axis, then a squared minus b squared is going to be positive anyway. But it's just I just always put the larger one minus the smaller one, and that gives me a positive number. And then so I have c squared is equal to positive number, and then I can take the square root. So you do see absolute value signs on the formula sheet, but that's just because you need to have a positive number so you can square root it to find c. So that's sort of the idea of what we're doing. So now we're just going to practice doing that. Here's our equation. So the center is always the easiest thing to find. So x minus 6 and y plus 1 are appearing in our equation. So our center is at 6, -1. And then notice that the number underneath the y plus 1 squared is the larger number. And so that means our major axis, this is going to be a taller ellipse. Like its major axis is vertical. I think if you're using your notes paper here, I think you have a coordinate plane. I don't have a coordinate plane here, so I'm just going to do a rough sketch. So I know this ellipse is centered at the point 6, -1. And so I know that in order to find the vertex here and the vertex here, those two vertices are 5 away from the center because 25 is 5 squared. So I have to think about counting up 5 from that -1 so that the 6 is the x-coordinate. This foci, or sorry, this is a vertex. This vertex at the top is going to also have an x-coordinate of 6 because these things are all along that same major axis. So they all have the same x-coordinate of 6. But we need the y-coordinate as well. Well, that distance to that vertex is 5. So from here to here is 5. So if I'm 5 above -1, that is at -4. And here we are 5 below the -1. So this would be negative. Oh, I'm sorry. That would be a +4. Sorry. It's late. And then 5 below would be -6. So starting at -1, we would count down to -6 or up to +4. So those are the vertices. So we'll put those in next, 6, 4, and 6, -6. And then last, we have to find the foci. The foci we can find using this formula, c squared is equal to a squared minus b squared. So our c squared value is going to be a squared minus b squared. So notice the a squared and the b squared are the numbers underneath in the denominators. Just always put the larger one first, and then you don't have to worry about absolute value. So, and again, I'm not squaring the 25 because 25 in this case is b squared. It's 5 squared. It's already been squared. So c squared is equal to 25 minus 9. That means c squared is equal to 16, and that makes c 4. So what that means is the foci are 4 above the center. So now I have to think about, what's this distance if I count up 4, 1, 2, 3, 4. That would put it, the first upper foci at 6, 3, because I'm 4 above -1, and the other foci will be at 6, -5, so 4 below. So I'm just subtracting 4 and adding 4 to get those foci. I think a sketch of the situation really helps. If you can do it without a sketch, more power to you. But I think having a little sketch helps. And if you need more of a coordinate plane, I just kind of have a pretty rough sketch. But, if you want a coordinate plane or to use some kind of grid to help you, that's also fine. This is kind of tricky, so we're going to do one more. This one is going to be horizontal. So we have a 169 is underneath our x plus 2 squared, so that's a larger number than 25. So this is going to be sort of a wide ellipse. So my major axis is horizontal here. The center of that ellipse, it's not a very good ellipse, huh? The center of the ellipse is at -2, -4. To get to the vertex on the right, I need to add 13 in the x direction. 169 is 13 squared. If I add 13, this time I'm adding it to the x coordinate because I'm thinking about moving to the right by 13 units. That puts this one at 11, -4. Every single one of those points is going to have a y value of -4 because it's that horizontal major axis. So this point over here, this other vertex, is going to be 13 units to the left of the center. Wow. That was like the worst brace I have ever drawn in my life, and you witnessed it in this video. Maybe I can't draw a brace anymore. Okay. 13 to the left. So that means I need to take away 13 from that -2. That puts this one at -15, -4. Again, it has that same y value. -15, -4, and 11, -4. Okay, so we found the center. We found the two vertices. Now we need to find the foci. So remember our foci equation, the c squared is equal to a squared minus b squared. That's 169 minus 25. So our c squared here is 144, which means our c is 12. So our foci is just inside there. It's 12 away from center, so that would make this first one at the point 10, -4, and then this one will be at the point -14, -4. Something I want to point out is that in both of my examples, the foci was 1 unit away from the vertex. That is not always the case. That just happens to be a coincidence on the two that I chose. Maybe a bad coincidence, but it is just a coincidence. So I would not assume that it's always 1 unit different. It's just that does sometimes happen. Okay. All right, so if you have any questions on those two topics, let me know. We've got one more topic. It is a word problem involving an ellipse. So we've got an arched bridgeway that is half of an ellipse, sometimes called a semi-ellipse, kind of like a circle is a semicircle. And you will always get a picture on this word problem topic, which is really nice. The arch, this particular arch is 164 meters long and has a height of 52 meters at the center. And then we have a point P that's located 11 meters away from the center. And we want to find the height of the arch above the point P. So we're looking for a height here. So first of all, what we're going to do is think of this ellipse as being on a coordinate plane. And we're just going to take the center of that ellipse to be the origin, 0, 0. So we're going to kind of make that choice. And what that means is that this equation is going to get a little simpler because this h is 0 and this k is 0. So the version of the ellipse equation that we're going to be using is x squared over a squared plus y squared over b squared is equal to 1. Okay, so the picture here and the words, I guess, are giving us the major and the minor axis. So in the x direction, the major axis, which is from the center to the edge, well, we know the whole width of that arch is 164 meters. So this axis is 82 meters. So that's just half of 164. That in the equation is the A. And that is not squared yet. That is just A. Our other axis, our vertical axis here, which is the minor axis, the shorter one, it is 52 in our equation. That is going to be B. Okay, so now we're going to think about this point right here on the edge of the ellipse. It's an x value and a y value. We know that its x value relative to the origin is 11, and the y value is what we're trying to find, the height. So we are going to use that 11 is going to be our x value, and we're going to solve for y. So we're going to sub into our equation an 11 for x. So we have an 11 squared in the numerator there. Our a squared value is going to be 82 squared. The y is what we're trying to find. And then our b squared is a 52 squared. Okay, so we have subbed into this equation, and there is only one variable left, y, which is the one that we want to solve for. Now, I would not calculate these values. I would not calculate 82 squared yet. You can if you want, but 82 squared is 6,724, and you're going to just be writing down all these really big numbers. I really prefer to just on my paper get the y squared by itself and then type in my numeric answer and let the calculator calculate it. So if I'm getting that y squared by itself, the first thing that I would do is do some subtraction. 1 minus 11 squared over 82 squared. Easier to just keep that fraction like that and not worry about getting a decimal answer yet. So right now the y squared is divided by 52 squared. So I'm going to multiply both sides of my equation by 52 squared. So here's what I have when I multiply by 52 squared, and now I'm ready to evaluate it in my calculator. So I like to get it into this form before I punch it into my calculator. 52 squared is being multiplied by 1 minus the fraction 11 squared over 82 squared, and we get 2,655.34. Now that is y squared. So then our last step would be to take the square root of that answer that we just got. And that gives us that y is equal to 51 point, let's see, round to the nearest hundredth, 51.53. Now, I would not assume these diagrams are to scale, but they can at least sort of help you decide if your answer is reasonable. We can see that this arch has a peak height of 52, and we're, somewhat close to the center, and we just calculated a number that is a little bit below 52. So that sort of makes sense, in terms of that this arch is slowly going down. So you can kind of check your answer for reasonableness. There's other variations. You are sometimes going to calculate the x value as well. So on this one, we can see that our major axis is 84. Our minor axis is 62. So that's our b value. This is A. And then if we think about this point right here, we don't know its x coordinate, but we know its y coordinate is 19. So we're going to use 19 for y. So again, if we center at the origin, we have x squared over a squared plus y squared over b squared is equal to 1. Subbing in for a squared, we get this. Subbing in the 19 for y, subbing in the 62 for b, we're going to work on getting the x squared by itself. First by subtracting, and then by multiplying. Whoa. This is going to be my most highest quality video ever. Okay, 1 minus 19 squared over 62 squared. So we first subtracted and then we times by 84 squared. We can evaluate that in our calculator now. And whoa, okay, let's see. 84 squared times 1 minus fraction 19 squared over 62 squared. And don't forget that this is not x, this is x squared. From the calculator, I get that x squared is 6,393.3527. Don't round too much on this step because we still need to take the square root. And so we get x is equal to 79.96 meters. So again, you can kind of use your diagram to decide if that's reasonable, but also realize the diagram is not to scale. It looks like it's sort of close to the center, but if this whole height is 62 and our height is 19, we're way, way farther to the edge. And so, in fact, this whole distance from center to edge is 84, and our point is at almost 80, so we're way over here by the edge, but you can still kind of check for reasonableness. All right, so that's it for our lesson on ellipse. Let me know if you have any questions. Thanks so much.